If you drive an electric vehicle in winter, you've probably felt it. One day your range looks normal. The next morning, it's gone. Not 5%, not 10%, sometimes 30, even 40%. So what's really happening? Is your battery degrading? Is something wrong with your car? Or is cold weather simply exposing how EVs actually work? Today, we're breaking down real numbers, not headlines, not opinions, but measurable data behind EV range loss in cold weather. And the truth might surprise you. First, let's clarify something important. Cold weather does not permanently damage your battery. What it does is temporarily reduce how efficiently the battery can operate. To understand this, we need to talk about chemistry. But don't worry, we'll keep it simple. Inside every electric vehicle battery, whether it's LFP or NMC chemistry, lithium ions move between electrodes to create energy. When temperatures drop, that chemical movement slows down. Slower ion movement means higher internal resistance. Higher resistance means less usable energy. And that translates directly into reduced range. At 20 degrees Celsius, your battery operates near optimal efficiency. At 0 degrees Celsius, efficiency drops noticeably. At -10 degrees Celsius, losses can become dramatic. Real-world data from cold climate EV testing shows. At 0 degrees Celsius, most EVs lose between 10 to 20% of range. At -10 degrees, losses often reach 20 to 30%. At -20 degrees Celsius, some models approach 35 to 45% temporary range reduction. But here's the key word, temporary. Once the battery warms back up, performance returns. Now let's talk about something most people misunderstand. The biggest winter range killer is not battery chemistry alone. It's heating. In summer, your car uses energy mainly to move forward. In winter, your EV is also heating the cabin, heating the battery pack, defrosting windows, running seat heaters, running steering wheel heaters. And unlike gasoline cars, EVs don't have waste heat from an engine. Everything comes directly from the battery. Cabin heating alone can draw 3 to 7 kilowatts depending on the system. That's equivalent to driving at highway speed just to stay warm. Now combine chemical slowdown plus heating demand. That's where the 30 to 45% winter loss numbers come from. But here's something interesting. Not all EVs lose the same amount of range. Why? 2 major factors: battery chemistry and thermal management. Let's start with chemistry. LFP batteries are generally more sensitive to cold temperatures compared to NMC. They tend to experience slightly higher temporary performance drops in freezing conditions. However, they are also more stable long-term and degrade slower over years. NMC batteries often perform slightly better in cold but may degrade faster over long high-mileage usage. Then there's thermal management. EVs with advanced battery preconditioning systems perform significantly better in winter. If the vehicle can warm the battery before driving or before fast charging, range loss is reduced. This is why preconditioning while plugged in is one of the most important winter habits. If your car is connected to a charger and you heat the cabin before departure, the energy comes from the grid, not the battery. That alone can recover 5 to 15% of lost range. Now let's address another common fear. Does winter cause permanent battery degradation? Short answer, no. Cold weather reduces available power temporarily. Heat is actually more dangerous long-term than cold. High sustained temperatures accelerate chemical wear. Cold slows reactions, it doesn't destroy them. However, repeated fast charging in very cold conditions without preconditioning can stress the battery. Modern EVs prevent this by limiting charging speed until the battery reaches safe temperature. So if your charging feels slower in winter, that's protection, not a problem. Now let's talk real numbers from winter range comparisons. If an EV gets 400 kilometers in mild weather, at 0 degrees Celsius you might see 340 to 360 kilometers. At -10 degrees Celsius, around 300 to 320 kilometers. At -20 degrees Celsius, possibly 260 to 280 kilometers depending on speed and heating use. Highway driving amplifies losses because aerodynamic drag increases in cold, dense air. Yes, cold air is denser. Denser air increases resistance. That alone can reduce efficiency a few additional % at highway speeds. So winter range loss isn't one single cause. It's a stack. Chemical slowdown, battery heating, cabin heating, denser air drag, cold tires with higher rolling resistance. When combined, they create the dramatic numbers people see online. But context matters. Most drivers do not operate daily at 20 degrees Celsius highway speeds. In moderate winter climates, real-world loss often averages 15 to 25%. Still noticeable, but not catastrophic. So how do you minimize winter range loss? Precondition while plugged in. Use seat and steering wheel heaters instead of blasting cabin heat. Keep tire pressure properly adjusted. Cold reduces PSI. Drive slightly slower on highways. Plan charging stops with buffer in extreme cold. These small adjustments can recover significant efficiency. Now here's the bigger perspective. Gasoline vehicles also lose efficiency in winter. Engines take longer to warm up. Fuel economy drops 10 to 20% in cold conditions. The difference is EV range changes feel more visible because range is displayed digitally in real time. Visibility amplifies perception. So is winter a problem for EVs? Yes, but it's predictable, measurable, and manageable. And most importantly, it's not permanent damage. It's physics. Understanding the physics removes the fear. And that's what this channel is about. No hype, just numbers. If you found this breakdown useful, consider subscribing to Evcarix for more real-world EV performance data. Because when it comes to electric vehicles, clarity beats speculation. Every time.